Some of the hardest problems in the world exist far above the planet. Our job? To launch the smartest solutions, to protect our satellites, clean up our clutter, to propel breakthroughs in propulsion, to learn more about our place in the universe, to outpace emerging threats. Every day, the Aerospace Corporation uses the latest technologies to ensure our nation's safety and leadership in space.
Hi, welcome to the Space Policy Show. Today we have a really exciting topic to talk to you about. So we are going to have Dr. Angie Bukley and Karen Jones to talk about locating methane super-emitters from space. It's a very interesting and timely topic, especially with what's going on in California, which Karen will talk a little bit more about. Just for future reference, we have moved our format to every Thursday. So we will be here Thursdays at 1 p.m. You can find us at aerospace.org/policy, or you can find us at aerospace.org/the Space Policy Show, all one word, no spaces or underscores. If you have questions or you want to engage with us, please use the hashtag the Space Policy Show. You can also comment directly under the Vimeo box. With that, let's go ahead and kick it over to Angie. She's going to do a brief introduction of herself and then also of Karen.
Okay, thanks for that, Rebecca. It's my pleasure to be here today to have this conversation with Karen Jones. She's going to be our featured expert, so I'm basically going to pepper her with questions. A little bit about myself. I am a member of the Human Exploration and Spaceflight Division, part of the Civil Systems Group at the Aerospace Corporation. My duty station is here in beautiful Houston, Texas. And I'm also a contributor to the Aerospace Center for Space Policy and Strategy. I did my graduate work at both Mississippi State and did the PhD at the University of Alabama, Huntsville. So I have to plug both of those places. I spent quite a bit of time working at the NASA Marshall Space Flight Center in Huntsville. And as part of my duties there, I worked in the Global Hydrology and Climate Center, which got me very, very interested in remote sensing applications. I was working on non-traditional activities, well, non-traditional at the time for NASA, like disaster management, urban forestry, agriculture applications, and things like that for remote sensing assets. I also was part of a study that was conducted in 2015 in Ohio as part of the International Space University Space Studies program. And we were looking, the name of the study was Tracking Fracking. And we were looking at emissions from fracking sites. So that's apropos for today's discussion. So now I'd like to introduce a person who's done most of the heavy lifting on this show today and on this particular study. Our featured guest is Karen Jones. She's a senior policy and strategy expert at the Aerospace Corporation's Center for Space Policy and Strategy. Before she joined Aerospace, Ms. Jones was a management consultant with IBM Global Services and Arthur D. Little, where she worked across a range of industries, including federal government, information technology, telecommunications, wireless technologies, remote sensing, satellite industry, environmental technology and services, oil and gas, mining, renewable energy. She did a lot of stuff. So early during her career, though, Karen was an exploration geologist in the petroleum industry and is very, very familiar with oil patch operations. Ms. Jones has an MBA from the Yale School of Management, and prior to leaving the oil patch, she was a third-generation exploration petroleum geologist. So, Karen, if you would, take a few minutes and tell us about this upcoming paper that we'll be publishing soon through the Center for Space Policy and Strategy.
Thank you, Angie. So the co-author for this paper is Dr. David Tratt, and Dave directs the Imagery Spectroscopy Department at Aerospace on our West Coast, and he has been responsible for leading the department on its mission to develop various sensor technologies and he focuses a lot on remote sensing sciences and technologies. So he was a huge contributor to this and to our ongoing work with spectroscopy and our sensor development at the Aerospace Corporation. So this paper, mapping methane emissions in the upstream oil and gas industry, examines current methane inventories, which are vastly underestimated, and understanding how these emissions occur in upstream oil and gas production is very important. It will help us in the future to find, prioritize, and mitigate these leaks and fugitive emissions. So what we propose in this paper is a practical tiered remote sensing approach using space, airborne, and ground systems. We also focus on California, and we'll be talking about a few fields that we flew over a 4-year period. But California has an opportunity here to lead and become the first state to control greenhouse gases. And they can start by gathering and fusing a vast amount of remote sensing data to create what we call actionable intelligence to mitigate the sources of these methane emissions. Also, the natural gas industry has an opportunity to essentially elevate its current position as the cleanest burning fossil fuel and begin to address the entire life cycle of natural gas production so that it can be not only a clean burning fossil fuel, but the extraction process behind natural gas is also a clean process.
Great, Karen. Well, thanks for explaining why this is a really good time to be looking at this topic. We know, I know from the studies that we did in Ohio that there are a lot of things that are emitted from these sites where they're fracking or drilling or whatever. We looked at things like carbon dioxide, methane, carbon monoxide, some of the precursors to tropospheric ozone, and things like that. We know that methane is a very potent greenhouse gas, but tell us why you really focused in on methane.
Well, methane is a rather short-lived greenhouse gas, but it's also why it's important to address it. During a 100-year period, it's 28 times as potent as CO2, but during a 20-year period, it's 98 times as potent. So you get a big bang for your buck by focusing on methane. So by reducing methane, I think we can make a quicker, kind of more effective advances towards reducing greenhouse gases. Methane is something that often is very preventable loss, especially in the upstream oil and gas production. It is something where there are huge economic incentives to be efficient, particularly in upstream oil and gas. So we think that with the right approach for finding these leaks, we can create a win-win situation for producers as well as environmentalists.
Yeah. So basically, methane is also a product and could represent income for these companies. So looking for this methane, how should we go about monitoring these methane emissions?
Well, there's a number of ways we can do that. There is the bottoms-up approach where we focus on representative sampling of targeted emitters by given source type, and then we scale up to create an inventory of what's there. You can see on this map what the top-down approach would look like. That's TROPIMI data. TROPIMI is JAXA's satellite. European Space Agency satellite, and you can see the giant hotspot, methane hotspot over California. So we can start by looking broadly as well, which is called a top-down approach, where you get measurements of ambient concentrations, and you estimate from that what the potential per well emissions might be to produce this broader image you see here. Actually, there's advantages to both approaches, and they should both be weighed against each other. The disadvantages for bottoms up is you don't always know what you should be looking for. So it depends a lot on what you're actually sampling, and you can miss super emitters. Conversely, by top down, you might end up looking at things very broadly and maybe even accurately from a broad perspective, but maybe some neighborhoods and some communities bear the brunt of the pollution. So you get into environmental justice issues there. Really, both are important to use and weigh each method against each other as you build your methane inventories.
Yeah, I understand. Thanks for explaining that. So now that you've explained how we look for those things, how should we prioritize our observations?
Well, I think there's been a lot of reports coming out lately about super-emitters. And these are those wells that are leaking significant amounts of methane or natural gas. And within natural gas, it's comprised of roughly about 87% methane. And we found some enormous methane emitters in the San Joaquin Valley, but others have found super emitters as well. Jet Propulsion Lab, for instance, found several in California. Environmental Defense Fund flying over certain areas has found quite a bit as well. So in the Permian Basin, for instance. So these super emitters pretty much exist in most of the production basins around the US and really around the world. And so if we can find those and prioritize and mitigate those, that will go a long way to reducing the overall methane emissions. And I think that's probably the best way to go about bringing down our overall methane count.
Okay, I see. I know that both Aerospace and JPL have done airborne surveys over 3 of the heavy oil fields in California. And these fields aren't really known for their gas production. So where exactly are these leaks coming from?
These leaks are surprising in the San Joaquin Valley because these are heavy oil fields. When I say heavy, I mean the API gravity, which is how the viscosity of oil is measured, is around 15 degrees. That's very, very thick. It does not flow well. Also, these are mammoth oil fields. They have produced millions of barrels of oil, and they have been producing for a century. So if there was a gas cap, it would have been bled off by now. So it's very interesting to see very significant methane plumes over these oil fields, Kern River, Kern Front, and Pozo Creek. They're operated by several different operators. They've been around a long time. You can see from this map here where we got methane hits. The little green dots represent methane emissions over 20 MCF, 1,000 cubic feet, MCF a day. So we had about 100. You can't see all the green dots here because they're overlapping. But it's significant, and it was surprising. So we started to examine further what could be producing this methane from these heavy oil fields. And one theory is that these fields are undergoing what we call cyclic steam injection. And that's when you've produced most of the oil out of the field, and now you're going back in for secondary or tertiary recovery to get the remaining amount. And that oil is rather stubborn. It's probably about 10% that's left in the ground. And you really need steam to pull it out, make the oil less viscous so it can flow. Possibly in the process of injecting that steam, the steam may have stripped off some lighter hydrocarbons, which have then escaped into the atmosphere, perhaps going up with the crude oil that's also being produced. But that is what we are seeing. And with our hyperspectral sensor, we can discern methane gas from water vapor and from helium and CO2. So we clearly know that this is methane coming up. It is not CO2, and it is not water vapor. And the rates are really high.
Wow. So let's zero in on one of these plumes that you're talking about so that we can, kind of get a better idea of what's really happening on the ground.
Okay. So what you see here is the imagery, hyperspectral imagery from our Mako sensor. These are methane hot spots. The survey was conducted over 3 years, 2015, 2016, and 2018. And we added a false color of orange so you can see what the methane plume looks like. And you can see that the methane is being emitted from what looks to be a pump jack. And in the lower right corner, you can see the shadow of the pump jack rig. And based upon our estimates, methane is leaking from this specific well, which has undergone a workover and has also undergone cyclic steam injection. It's emitting 82 MCF a day. Now, revisiting that same site on 2 consecutive years, you see that it's still venting this methane. What's interesting about this is that the reported amount of methane is 115 MCF a year, but we're actually getting a rate of 82 MCF a day. And if you assume it's producing on a daily basis, then that's over a 25,000% leakage rate. That's huge. Now, certainly other fields are leaking large amounts of methane as well. There's been some studies done over the Permian Basin, and the Permian Basin seems to be leaking at maybe 3.5%, which is very high because it also produces a huge amount of methane. So yes, this field is not really producing much gas. It's really venting most of it. And that was one of the surprising results from this survey. We don't know all the reasons. I do want to mention here that now is a very challenging time for this country. Today, the price of oil is $25 a barrel. At one point, it was strangely a negative price because producers couldn't unload their crude. There was a backup as far as inventory. But we're now at $25 a barrel. For U.S. domestic production, which for gas, which largely relies on shale, this is a very low amount. The break-even point in the Permian Basin for oil and gas production is around $42 a barrel. For some shale plays in other parts of the U.S., we're looking at over $50 a barrel. So we're really far off that mark. So what does this mean? We could end up with more insolvent operators. And the more bankruptcies that occur, we could see an increase in orphan well numbers. These are wells that have been abandoned without properly plugging and abandoning them. So it is a problem. It's been a problem for years. Certainly Ohio, Oklahoma, Louisiana, Texas, and California have all had problems with orphan wells. But add on top of this very low oil price and the increased number of bankruptcies that we might see, and it becomes an even larger issue. And that is something we are concerned about, but it's also something where I think we can address this with appropriate remote sensing. This gets back to where are those super-emitters? Where are those emissions occurring? Some of them could be occurring in idle wells, inactive wells, or orphan wells. Understanding where they are is very important, particularly if some of these oil and gas assets change hands over time, they go from one bank to another. And understanding prior to any kind of transfer of ownership, understanding the environmental condition of these wells is extremely important. In the state of California, they estimate just to plug their idle and inactive wells, it will cost the state over $500 million. And to plug all active or idle wells would cost $9 billion. So it's an extremely important issue, and it's a very expensive proposition for a state to absorb the cost for this.
Wow, it sounds like it is a very serious problem. But, you know, we're getting more and more data and information, and studies like Aerospace and JPL have done reveal a lot about what's going on. What changes might we expect as the state of California focuses on these upstream oil and gas emissions and finding them, prioritizing, and hopefully mitigating these super emitters?
Well, I think they need a tiered remote sensing strategy approach to really address this issue. You know, starting with space, then airborne, and then ground-based. I think they really need to establish that type of program. But the good news is there are some emerging satellites that could be part of the solution. For instance, we have some satellite data available now. Greenhouse Gas Sat out of Canada has commercial data available for subscribers. This is not free, but certainly California could acquire some of this data. There's a Chinese satellite that has a number of payloads available, and they claim to be able to see methane as well. Also, the Environmental Defense Fund is looking at launching a satellite called Methane Sat, and that's going to also target methane emitters, and it's going to launch again in 2022. TROPIMI, European Space Agency satellite, is a very interesting one, and it's free. So it's a good place to start to begin to see what are those regional anomalies. If you start with TROPIMI data, you can work your way down and start to conduct some airborne surveys using advanced hyperspectral airborne sensors, such as Aerospace's Mako sensor, or perhaps Jet Propulsion Labs' Avarice sensor, that are able to detect methane, that are very sensitive to methane. So these are some approaches, and certainly ground truthing. That's always a good thing to do in the end, to go out and sample the air.
Yeah. And then you can really pinpoint where things are coming from when you do that.
Exactly.
So, you know, U.S. Oil and gas operators have been drilling and producing oil in the United States for a long, long time. But they rely on state regulatory entities like the Texas Railroad Commission and the California Department of Conservation, Geologic Energy Management, and they depend on these agencies to tell them how to operate according to the guidelines. This raises another question. How did these super emitters remain unknown for such a long time? If there are all these regulations and they're supposed to be following them, how did this kind of get by everybody?
I think it did because when you do ground-based surveys, you don't know what you don't know, so you don't go to where these super emitters might exist. Also, hot air rises. So if you have someone on the ground with an air sampler, they're not going to be in the plume to detect the methane. So that's one. Two, these fields are very vast, so you really have to know where to go. So, you know, it's sneaky. These heavy, large emissions could be in places that are not typically sampled. This specific slide here, compliments of JPL, shows coal bed methane. Certainly the oil and gas industry isn't the only industry that has these super emitters. And it's basically showing that there are large concentrations of methane coming out of few sources. And this occurs across a number of different industries. So if we can find those, we can really go a long way towards mitigating the overall methane emissions in this country. So I think getting back to the regulators and how they can operate, I think they really need to start thinking about what is best available technology. And best available technology has changed over the last several years. And hyperspectral sensors, multispectral sensors have come a long way. They've improved their spatial resolution and their spectral resolution. They're able to discern between a number of different gases and solids. They need to be part of the equation, part of the enforcement equation. I also think operators could welcome this. It's not just about enforcement. Remember, in the pipeline industry, a small leak becomes a bigger leak over time, and they know that. And I think pipeline operators want to be 100% clean. I don't think they want to see this happen. So I think there's a lot of things we can do to reward good operators. One idea coming out of Resources for the Future is to create kind of like a green label for gas producers that can produce below a certain percent as far as leakage rate. And I think by doing that, the gas industry could elevate its position, and it's currently the cleanest burning fossil fuel, but they could elevate their position even further and become clean cradle to grave. Because right now, if you're looking across the various production basins, whether it's the Bakken Shale, Uinta Basin, San Joaquin Valley, Eagleford Shale, Permian Basin, they're all leaking at various rates. And I'm sure they all have super emitters. Let's find them. And let's use a systematic approach, top down and bottoms up, to find them and to mitigate these leaks.
Excellent. That sounds like a really good way forward. We've talked a lot about, sensing and finding and identifying, but let's take a step back now. I mean, we've talked about at least 3 tiers of sensing, and that's ground-based, airborne, and space. What can we expect in the future from a space infrastructure perspective? Are there any methane hunting satellites available right now that are just specifically focused on this issue? Or are there any in the planning right now?
I think it's a very exciting time. I think there's probably some things being planned that I don't know too much about yet. Things are still rather confidential. But there's a few exciting things. First of all, getting back to the Canadian Greenhouse Gas Sat, you can acquire that data and start to look at that. I imagine there will be a lot of oil and gas operators acquiring those data sets to look at, what do their fields look like and where can they improve. Environmental Defense Fund launching Methane Sat. That's going to be a very exciting thing as well. And this apparently will focus specifically on oil and gas facilities. It's got a 200-kilometer wide field of view, and it's going to cover the Earth in roughly every 7 days across these major oil and gas producing regions. So that will be very exciting. Again, this is still in the planning phases. And then you have a rather new player that's come onto the scene called California Sat. And I think it's California is looking at how can we be part of this equation, and should we launch our own satellite? I don't know too much about it yet, but I've heard that there are some discussions in play, and I've seen various news releases about this. There's a lot of interest in methane, and it is a type of gas you can see from space with the right types of hyperspectral instruments.
Wow. Yeah, maybe Texas could get their own satellite too. That would be pretty cool.
Texas Sat, yes, Lone Star Sat.
Texas, yeah. So the work that has been done so far between JPL and Aerospace, looking at the situation in California, it's revealed some very disturbing facts and issues, and it really kind of mirrors the study or what we found in our study in Ohio. But on the plus side, we know that there are ways now of detecting these emissions, getting the data and information in front of the right people, and hopefully having some influence on all the stakeholders, because as you said before, methane is also a product, and that these producers don't want to lose anything like that. So I think there's a bright future, hopefully, that we can identify all these super emitters and hopefully address the situation. Karen, do you have any final remarks that you'd like to make before we close out?
Well, as you mentioned, stakeholders. I'll mention one other, and that is the mineral rights owners. They get royalty checks based upon production. I doubt they want to see their gas that they pretty much own going into the atmosphere. So they're a huge stakeholder. But I don't think anyone really wants to see these methane emissions occur. I think with the right instruments in play, operators can quickly mitigate these, working with enforcement quickly, particularly these super-emitters.
Wow. Okay. Well, Karen, we really appreciate you taking the time today to have this conversation. I think it's been very insightful. It's been very good to find out the kinds of things that are going on to try to identify these super-emitters and hopefully have an influence on the outcome. I'd like to thank the audience and everyone who's joined us for this discussion. And hopefully we've provided a few points for you to ponder throughout this discussion. Thank you very much.
Thank you.
Back over to you, Rebecca.
Thank you so much, Angie and Karen. We really appreciated you taking the time to educate us about these methane super-emitters and the impact that they're having. As you recall, we can engage with these experts 2 different ways. So I want to reiterate that here. Please send your questions through Twitter, #TheSpacePolicyShow, or you can comment in the Vimeo video comment box right below the video you're watching. And next Thursday, we have The Value of Space with Sam Wilson and Dr. Mick Gleason. We also have a couple of other people, special guests, who will be participating. We've got Marina Corin from The Atlantic, who will be moderating that panel. So definitely stay tuned. And again, sign up for our alerts. You can find our sign up at aerospace.org/policy. And until next time, we look forward to seeing you.